film it again. All right, here we go. If you're at home and you just did the practice problems on part 1, the next time you come into class, get the key from me and check your work. Thanks. We're moving on. All right. Now, let's talk a little bit about 6.02 times 10 to the 23rd. It has a name. It's called Avogadro's number. Okay? Now, all right, listen up. Avogadro's number is 6.02 times 10 to the 23rd. Okay? His name is not like crazy important, although I will tell you that what happens is, anybody need the key? I will tell you that what happens is, sometimes on the SOL test, instead of them just saying a mole, or instead of them saying 6.02, they'll say, if you had Avogadro's number of, and they ask you a question, and it's like, instead of just saying if you had 6.02 times 10 to the 23rd, they just say that. You understand what I'm saying? Now, when I was learning chemistry for the very first time, I could remember his name because I just remembered avocado, and that's what you use to make guacamole, and like mole, avocado, avogadro. You follow what I'm saying? That's just how I remembered. Okay? So, that's how you make guacamole, is with avocados. Okay? So, alright, Avogadro's number 6.02 times 10 to the 23rd. Now, let's talk about the scope of this number. Okay? Because even though we have the times 10 to the 23rd, this is a rather neat package in terms of the number. Okay? Now, if you had Avogadro's number of sheets of paper, that means that you have 6.02 times 10 to the 23rd sheets of paper. That means that you have a mole of sheets of paper. And you stack them one on top of the other. The stack of paper would go out of the solar system, as in the Milky Way. What? What? Crazy. The next one is my faith. If you had Avogadro's number of pennies, so you had 6.02 times 10 to the 23rd pennies. You had a mole of pennies. And you gave 1 million pennies. That's $10,000 if you want to do the math like that. If you gave 1 million pennies to each person on Earth, current global population is about 7.5 billion. Gave every person 1 million pennies every day. It would take you 3,000 years to get rid of the pennies. Now, are you going to be asked on the SOL test about how many pennies you have to give away and how much time? No. Why do I give you these? Why am I telling you this? What? Okay, yeah. But what? To try to wrap our brains around the size of the number. Do you understand? 6.02 times 10 to the 23rd. It's like, it's neat. Do you understand? You're like, oh, 6.02 times 10 to the 23rd. How big is the friggin' number? It's so friggin' big. Why could we not have Avogadro's number of sheets of paper? What's paper made out of? Trees. Are there enough trees on planet Earth to make that much paper? Not even close. Not even close. Why could we not make that number of pennies?
It's not enough copper.
There's not enough copper. And there's no, all of the money in the world is not equal to that much money. Do you understand? All the banks and all the countries in all the world is not equal to that much currency. Okay? Plus we could not, there's not enough. If we took all of those pennies and put them together, the mass of pennies would be bigger than planet Earth. Okay? The number is insanely large. And yet, if I have Avogadro's number of molecules of water, I have about a teaspoon. A teaspoon of water contains, 6.02 times 10 to the 23rd molecules of water. So it's a huge number used to talk about what?
Very small things.
Something that's very small. Is it practical? Is it relevant to talk about Avogadro's number of sheets of paper? No, we can't do that. I can't send you to the store to get Avogadro's number of donuts. We don't have enough raw materials to make Avogadro's number of donuts. Okay? Not even close. And we think about really big numbers. You think about the national debt. I don't know what it is now, but it's something trillion. Trillion. Whatever. That's like 10 to the what? 7? 9? I don't know. Whatever. They ain't nothing. Okay? You got debt, Avogadro's number debt. You got troubles. Okay? You ain't never coming out of that. Now, let's talk about a little bit of terminology. Okay? When we say the word atom, we are talking about a single unit of an element. I have atoms of hydrogen. I have atoms of copper. I have atoms of phosphorus. I have atoms of neon. Okay? These are things, elements are written exactly on the periodic table. They are made of atoms. If, for example, I have 1 mole of neon, I have 6.02 times 10 to the 23rd atoms. I'm talking about neon, which is an element, so I use the word atoms. It has a mass rounded to the nearest whole of 20 grams. Where does the 20 come from? Of neon. Yes? Okay. The word molecule is the word that we use to describe a single unit of a covalently bonded compound. So, if I have 1 mole of water, I have 6.02 times 10 to the 23rd molecules. We use the word molecule because water is covalently bonded and it is a compound. It has a mass of 18.02 grams. Where does the 18.02 come from? Directly from the periodic table? Is 18.02 written on the periodic table for water? No. How do we get it?
2 hydrogens and 1 oxygen.
What about the hydrogens? What is that? Hydrogen's what? Hydrogen's what? Hydrogen's mass times 2 plus the mass of oxygen, yes? Okay? Now, if I use the word formula unit, if I use that term, formula unit, I am talking about a single unit of a substance that is ionically bonded. So, for example, if I have 1 mole of magnesium oxide, that means I have 6.02 times 10 to the 23rd formula units of magnesium oxide. Formula units, we use that word because it's ionically bonded. It is a left thing plus a right thing. It is a positive thing plus a negative thing. It has a mass of 40.31 grams. Where do you think the 40.31 grams comes from? How do we get that? I typed it in the PowerPoint because I have it memorized. The formula mass, the molar mass for all compounds are in my brain. Where does it come from?
Atomic mass of the elements.
Okay, how many in which?
It was
40.31 must be the mass of
one magnesium,
1 magnesium
one oxygen.
plus 1 oxygen. Yes? Easy peasy? Troubles? Okay. Now, I have a brief homework assignment. I'm going to put it up on the screen in just a sec. I think it's 4 problems. Maybe 5, I don't know. 4 or 5 problems, okay? That's homework assignment number 1. Homework assignment number 2, we are taking a quiz on this tomorrow. This is going to be yesterday's notes, today's notes. You can bet that the bulk of the quiz will be calculate the formula mass for this, calculate the molar mass for this. If you can't write the correct formula, you're going to get them wrong. Am I going to give you a list of polyatomics? You're going to be able to look that junk up? No. It's over. Remember, training wheels off. I'm sending you down the driveway.
Now here we go.
Okay? So, 5 practice problems. Okay? I said 4 or 5. That's what I said.
Do we need a new piece of paper for this?
Ma'am?
Do we need a new piece of paper for this, or just we do that?
You can do it on your notes. Yeah, you'll have to turn them in, and probably I'll do a quick, fast completion grid while you're quizzing. But yeah, you can do it on your notes. As long as you can take your notes out of your binder. Be sure that you're writing this down correctly. Formula mass, chromium. Molar mass, hydrosulfuric. Molar mass, triphosphorus monosulfide. Number 1 and number 4 will have what unit? Number 1 and number 4 will have what unit on the answer? AMU. 2, 3, and 5 will have what unit on the answer? Graham, listen to my words. On the quiz tomorrow, you're going to have to do that. I'm going to say calculate formula mass, you got to give me AMUs. I'm going to say calculate molar mass, you're going to have to give me grams. Yes? You got to know that. So, this is homework assignment number 1. Completion grade due at the start of class tomorrow. Homework assignment number 2 is prep for the quiz. Don't forget to look at your notes. There'll be maybe 1, maybe 2 notes type questions. The bonus, if you care to know this in advance, is an old SOL question, so it's a review question.